All right, let's look at another example here where maybe we want to look at the change in concentration of, say, a single species. One possible way we can model this is maybe with an equation that looks something like this, where we have the concentration at any given point in time is equal to the original concentration of that species times e raised to the power of negative kt, k being the rate constant, t being time, right? And so if we know values of uh, our concentration of A at different time intervals, right, and we were to plot that on a graph, it might look something along these lines, where I have the concentration of A on my y-axis and then the time on my x-axis, and I might see data points that look something along this line, where I have a linear trend between the concentration of A and time. And so I want to model this equation and turn it into a linear form, so I need to do a linear transformation. And I can do that by taking the natural log of both sides of this equation, so that I end up getting Ln times the concentration of A time is equal to Ln, the concentration, my original concentration, minus Kt. All right. And if you need to convince yourself of that, you can go back and look at your natural log, your logarithmic rules from algebra, I think, and you'll see that that does work out. And so this form here, all right, taking the natural log of both sides, so I multiply both sides by Ln, okay, and I end up getting, all right, this linear form where my y, all right, equals, this would be our mx and b, all right, our y-intercept. And so now if I plot this information, or if I were to plot this in a graph, where my y-axis is not now our concentration of A, but the Ln concentration, the natural log concentration of A with respect to time, then I will see a trend line where I have a linear relationship between the natural log of the concentration of A and time, and where I can also identify a couple of things. One is the slope of this line, all right, if I look at that, will end up being, all right, my rate, all right. So if I don't know the concentrate, or if I don't know the rate, I need to determine the rate at which this species or this concentration is deteriorating or going away, all right, I can just calculate the slope of this line, all right. But also my y-intercept, all right, is the natural log of my original concentration here, okay. See, my y-intercept is my natural log of my original concentration. So if I want to know what my initial concentration is, all I have to do is use, well, B equals the natural log of the original concentration, okay? And so if I take the exponential of both sides of this, all right, and rearrange my equation, I'll get the original concentration is going to equal, all right, the exponential of B. All right, and so then I can determine what the original concentration is, or I can determine what the rate of something is. Pretty cool.